Hello and welcome to the Denim Group webinar. I'm your host, Nan Palmero. During the presentation, all participants will be in listen-only mode, and we ask that you mute your phones. Following the presentation, we will conduct a question and answer session. At that time, if you have a question, please use the chat feature. As a reminder, this conference is being recorded. Following the webcast, you will receive a follow-up email containing a link to the video replay. Today's speaker, Dan Cornell, is a globally recognized application security expert. He holds over 15 years of experience architecting, developing, and securing web-based software systems. As Chief Technology Officer and Principal at Denim Group, he leads the technology team to help Fortune 500 companies and government organizations integrate security throughout the development process. I would now like to turn it over to Dan for the presentation.
Thanks, Nan. Well, welcome everybody. Thanks to all of you for coming out today. And today what we're going to be talking about is looking at how two different mobile operating systems, iOS and Android, handle security. And our hope is that this will be of interest both to developers as they try to understand the capabilities from a security standpoint, the capabilities of the operating system that they're developing for, as well as to provide some additional information how they can find further resources, and as well as for security professionals trying to assess the risk for their organizations as they deploy mobile applications across different operating systems. A little bit of background about me. Again, my name is Dan Cornell, as Nan said. I'm one of the founders of and the CTO of Denim Group. And I'm a software developer by background. I started doing a lot of, in the mid to late 90s, a lot of some early Java server-side work. In the early 2000s, I did some early .NET work. But what I've really focused on for the last decade is looking at how software developers, as they develop software systems and deploy them in different organizations, what those software developers do impacts the security of the organizations deploying that software. And with mobile, you're looking not just at how the organization security is impacted, but also how the security of the users of that software is impacted. And so that's what I've really spent a lot of time on. But culturally, I'm a software developer by background that has come into the world of security as opposed to being someone with a more traditional network penetration testing background that's now looking at web and mobile applications. And so when I look at mobile application platforms, my question is, what are the capabilities of the platform, but also how do those capabilities work? And as developers build software, how can they best take advantage of these platform features and these capabilities, and how can they use secure coding techniques in order to build software that is going to protect their organizations and is going to protect the users of this software? I'm also, I do a lot of work with OWASP. I'm one of the leaders of the OWASP San Antonio chapter, as well as contributing to a number of projects. But again, my perspective is one of a developer that's come into the world of security as opposed to a security person looking at web and mobile apps, and that colors this perspective a little bit. Just a little bit of background on Denim Group. We build and secure enterprise applications, both web and mobile. We do a lot of secure development for organizations, secure remediation, helping them fix vulnerabilities as well as to build systems new that are resilient against attack. We also do a lot of application testing. So if you've got a need for application testing, mobile application testing, SDLC consulting, we help out with that as well as for training. We also developed a ThreadFix application vulnerability management platform that a number of organizations we work with use to manage their mobile application security programs. Just a little bit of little bit of background. We're going to be looking at two different mobile environments, iOS and Android. And the topics that we look at here for specifically iOS and Android, you could also ask these same questions about BlackBerry, about Windows Mobile. Again, for our purposes today, we're going to focus in on iOS and Android, just because we see those, just in our experience working with a lot of organizations, those are the most dominant. We also do work with Windows Mobile, with BlackBerry, but the majority of the stuff that we see for the large enterprise environments we work with, centered on iOS and Android. And an interesting thing from the security perspective, a lot of times you would like to have some choices about the platforms you develop for, looking at it from a security standpoint. But what we see in most organizations is the environments they develop for is not guided so much by the development of the security department, but instead is driven by client or by their customers' demands. There was one environment we were working in And you know, a representative from the security team says, we should only develop our mobile application for BlackBerry because they have ephemeral keys, and I like the way that they do crypto, and these other guys don't know how to do crypto right. And so that's a very interesting perspective. You know, what percentage of your mobile users are using their BlackBerry or using the BlackBerry application? And the response was 10% and shrinking, so we're about to end of life it. And I think that's an important lesson to understand when you're looking at mobile application security. You know, your customers are typically going to be the ones that drive the platforms you have to develop applications for. And as a result, they're the ones that are making certain security decisions. And the question is not which platform should we support for security. The question instead is, when we develop applications for these platforms that are in demand, how do we best use the security capabilities to create software that is as secure as is possible or as reasonable in these environments? And I think that's an important thing to understand when you look at mobile application security. Today we'll be looking at, just from an overview standpoint, looking at the overall challenges of secure mobile development and how that differs a little bit from web application development. Then we're going to drill into a couple of different areas of concern. Looking just first at the basics of application development and the basics of secure application development. What does the landscape look like for these two major platforms? Then we're going to look at how you can securely store data at rest on a mobile device and what the kind of pros and cons of this are. We'll also look at how you communicate securely from these mobile devices. Mobile applications or mobile devices are very interesting because a lot of code or a lot of portions of the application can rely on mobile browsers and their behavior. So we'll look at how those are handled differently between the different platforms. Then we'll look at things like SMS and push messaging. Again, interesting and peculiar to mobile devices. And finally, we'll look very briefly at licensing and in-app payments and some of the facilities available there as well. And we'll have time for questions and answers at the end as well. So if you have a question, please submit it. And again, hopefully, based on time, we should be able to get to a number of those. One thing that I will point you to that's a great companion resource for the webinar that we have today is the Denim Secure Mobile Application Development Reference. And really what that is, it's going to go through the same topics at a slightly finer grain than we'll talk through today. And what it provides is more in-depth information as well as links to additional resources. And so, as we'll talk through things today, we'll make this slide deck available. The next layer down, it peels the onion back one more layer. You can look at the Secure Mobile Application Development Reference. And that's it's a document that we update on a periodic basis to try and keep it fresh, but that provides this type of information for two different audiences. The first is for developers so that they can look and understand, hey, I'm going to start developing an application for an Android environment. What are the things that I need to take into account that are peculiar to the Android platform, and where can I reach out for more resources? For security professionals, this lets them look and say, hey, we're going to be developing mobile applications. How do I need to think about data storage? How do I need to think about data communication? And then, again, giving them the ability to drill down and look at more specifics for the particular platforms that your organization might be targeting. That's available online. Again, these slides will be available, and we've got links to that as well. Great, hopefully a very useful resource for those two different sets of consumers. So let's look at the challenge of secure mobile development. One of the really interesting things, or the cool things that I've seen over the past couple of years looking at security for mobile applications is the threat model is a lot more complicated than a standard web application, because you don't just have, in a web application environment, you've got bad guys outside the firewall, and they are sending requests to your web browser, or sorry, to your web server, where you get to make decisions about what to trust and what to do. In a mobile application environment, this gets more complicated because potentially a lot of the data and the processing has to reside on this mobile device. And this mobile device is something that you don't control. Hopefully you control your servers, you don't control your users' mobile devices. And that's especially the case looking at applications that are going to be used by the general public. If you're looking at internally focused applications, maybe you can do some mobile device management. You have more control over the devices that people use if you're looking at corporate users for applications. But if you're looking at the general public using applications, again, as we talked about before, you don't have a lot of control over what platforms they want to use things on, and you're typically not in a situation where you can use mobile device management to manage these untrusted devices because, I mean, hey, I'm not going to, for a given, bank or something like that, I'm not going to give a bank control over a mobile device. My device is my mobile device. And so you're really moving from a more straightforward threat model to one that's more complicated. But for the purposes of today, we're going to be focused on the code that's running on the mobile device and the capabilities that the different mobile device platforms have to help enforce the security requirements. Now, this is a slightly more detailed view of the threat model, but again, at the center, you have code running on the mobile device, the mobile application that you create. You're storing information potentially on the mobile device. Maybe that file system has been compromised. We'll talk about jailbreaking. We'll talk about rooting. Maybe this user, is malicious, but maybe they're not. Even if they're not malicious, maybe they have inadvertently installed malicious mobile applications on this device. So that's something that you may need to pay attention to from a design standpoint. Most interesting mobile applications are making calls back to enterprise web services. Again, a little bit out of the scope of what we're talking about today, but these enterprise web services can be targeted directly by attackers, not just through your mobile client. And a lot of mobile applications that we look at use third-party services to provide some sort of capabilities. And so as you see here, there's a lot more trust boundaries on a mobile application threat model typically than you'd see in a more standard web application. And so you've got a number of different mobile threats. Users that are, may try to spoof themselves to the mobile application, users that may try to spoof themselves to the web services, folks that may want to tamper with your mobile applications or tamper with data stored in the device, getting data off of the device in a case of a lost or a stolen device, some sort of information disclosure of the mobile application communicating with the web service over insecure channels. Potential denial of service, ways to stop the mobile application from working, or getting either the mobile application or the web service to act at a higher level of permissions. Again, we're going to be focused today on the code running on the mobile device, but it is important as you look at the security of your mobile applications and of the implications of mobile application development on the security of your organization, to be able to understand and spend some time thinking about what are the different areas or what are the different threats that we're concerned about, both on the client side as well as on the server side, and what sort of countermeasures are you going to look to put in place in order to guard against these things. So there's a number of different areas of concern that we want to talk through. And we'll start out looking at the basics of secure application development, which really will start with the basics of just application development, and then look at the types of security resources that are available. Again, then we're going to look at securely storing data at rest, securely communicating data when it's in motion. We're going to look at mobile browsers, SMS handling, and licensing and in-application payments. So the first is looking at these basics of secure application development. And this is one of the things we've seen as the development of mobile applications has taken off. The demand for mobile application development has increased. A first thing that, or a real challenge that a lot of folks have trying to develop secure mobile applications is the first thing they need to do is learn how to develop mobile applications. And so that's a real challenging thing in a lot of organizations. They have developers that are both learning about secure development, maybe they don't have a lot of background in secure coding to start with, but they're also trying to learn mobile development. And so you have to, you can't expect people to write secure mobile code until they both know how to write secure code and know how to write mobile code. And so that's, again, just because the average tenure of a mobile application developer, if you look across the entire industry, the average tenure is pretty low because people are just, now getting into mobile application development. That presents a certain set of problems for folks. Just figuring out how do I, in this environment, how do I pop up this widget on the screen where I want it to go, right? Like that takes precedence over secure coding. You've got to be able to make the application do what you want. So if we look just at an overview of application development, A theme that will kind of come up over and over again is that in an iOS or in an Apple environment, they've got a very strong control over the ecosystem of the devices that are available and of the capabilities that you have. Whereas Android, again, has a little bit of a different target use case of being available to multiple handset providers, and so you see a lot more variability. In an iOS world, applications are typically developed in Objective-C, compiled down to ARM machine code. Newer applications, Apple in 2014 released the Swift language. We've seen some uptake of that, and as we'll talk about later on, there are certain things from a security standpoint that Swift does better, or it makes it harder to cause problems than Objective-C. But as we'll also see, that it's not a blanket case to say that Swift is a secure language. The iOS developer program allows you to sign up and to develop and install applications on test devices, and your applications are typically going to be, for a non-jailbroken device, your applications are going to be installed by the common user, from the iTunes store. In an Android environment, applications are typically written in Java. There's some frameworks that allow you to do some other stuff. Originally, the Java gets compiled down into DEX bytecode rather than Java bytecode. Similar but different, same concept, but structurally a little bit different. Earlier versions of Android used the Dalvik virtual machine. More recently, the Android runtime, or ART, is the environment that those applications run in. And an advantage in certain cases is that with the Java language and the implementations of the Dalvik and the Android runtime, those provide, in the default case, those don't have pointers, and they provide certain memory protections that you don't necessarily have in Objective-C and Swift environments. And so, that's, again, from a secure coding standpoint, it makes it harder to make certain types of errors in an Android environment. Applications for Android installed from the Android Play Store for a typical user, but they can also be side-loaded via USB to the applications. And so in an Android environment, you have more ways in the general case to get applications onto a device. The good news is that both Apple and Google provide a lot of resources, or a number of resources out there that can help developers learn about secure development. Obviously, just for general development, both platforms have a lot of things out there. But Apple provides a really good, what I consider to be a really good secure coding guide. And the reason that I like Apple's secure coding guide is that it has both general secure coding recommendations, talking about things like input validation and encoding, which is good to do regardless of the language, but they could put it in the context of developing for iOS. And they also have iOS or platform-specific recommendations in there. And that's I love to see that, because too often secure coding guides focus on one or the other. They either say, here's in general how you do secure coding, here's the concept of authentication authorization, or the concept of input validation, and they don't talk about specific capabilities. Or those guides look only at security features or security capabilities and don't provide a background on general secure coding. So one of the things I really like about Apple's guide is that their secure coding guide has recommendations in both of those spheres. Android also provides some resources out there. Google has a Google group that talks about secure Android coding. And I'd say in the Android world, there's also a number of third-party resources available as well. So there's, again, in both environments, there are secure coding resources out there for developers that want to learn more about those. And again, we've got more specific links to those inside the secure development reference. And so please pull that down and take a look at those. In both environments, the platform attempts to provide a certain set of guarantees, all right, and about how the environment is going to work, and to limit what an application can do. Part of that is, again, to provide some isolation to protect against malicious applications from doing bad things. Part of it is also to protect certain organizations' business models to make sure that they get their licensing revenue. Again, these things can be kind of all over the place. And an iOS device, you can jailbreak the device that will allow you then to operate on the device as the root user and potentially to install applications, third-party applications that haven't been through Apple's approval process for the iTunes Store. So it allows for the use of alternate app stores, and that's potentially of interest to a user of an iOS device to get away from some of the restrictions if they want to load things from other places. The danger there is that you're stepping outside the protections that the iTunes Store provides, the curation that they do for applications and things like that. And so that's something to be aware of. There are some methods that you can use in your applications you might be developing to try and detect devices that have been, jailbroken. Those meet with varying degrees of success. But again, that's a concern that we've seen for certain customers, is to say we don't want our applications running in these environments, because then, again, the application might be running a debugger, might be subject to people trying to misuse it, do other things like that. In an Android device, you have a similar capability, except it's called rooting. Again, allows for root-level access to the device and may allow for custom kernel loads. Android as an environment is based on the Linux operating system, and so is open source. And so there are a number of custom kernels that have been developed that allow you to do different things. Again, the challenge or the risk there for a user of those devices is, as you start to break down some of these restrictions that are in place based on the Android, the assumptions of the Android environment, that user then steps out from the umbrella of those protections. In some cases that may be acceptable to them because they want to load, applications from different app stores or things like that. But that's, something to be aware of as a user of these. Also something that you may want to pay attention to from a detection standpoint for the applications that you're developing. For installing applications, again, on non-jailbroken iOS devices, the typical path to do this for a general user is the Apple iTunes Store. Also, developers in the developer program have the ability to install applications on a limited set of test devices for testing. And in the case of jailbroken applications, there are alternate app stores where you can install devices. Install applications. In the Android world, you have the Apple Play Store, and that's the typical place where you're going to get applications as a user. You also have the ability to sideload applications over USB, for development and debugging, but also for general usage. And again, there are also alternate app stores for rooted devices. One thing that I would say, just from a qualitative standpoint, if you look at the validation of the verification process that these app stores put in place, what we see is Apple has I would argue, a comparatively stringent process for vetting applications, and they kind of make some hand-wavy things about the security checks that they might be doing for applications. I would argue that a lot of the validation that they apply is designed to make sure that you're not encroaching on their business model or trying to subvert that. But they do have a vetting process that you have to go through. Also looking at things like how your user interface works, and trying to look for malicious behaviors. I would argue that Google approaches this from the alternate side, which is to say, originally we're going to let everything in, and then we'll pull the bad apples out as they're identified. They've gotten more aggressive, more proactive, let's say, in curating applications, but still, I think from a cultural standpoint, you see that the iOS world is more of a walled garden for applications, whereas Android, and Google allows for more than where they then go and identify the bad apples and and remove those. If we look at the application permission models, looking to see, inside of an application, what is this application allowed to do? A defining characteristic, or one of the reasons that mobile applications are so cool, is that you've got a computer in your pocket that knows where you are via GPS, can talk to things over the internet, has access to your communications via email, via SMS, can record audio, can shine lights on things, can take pictures, can take video. Right? That allows for the creation of whole new classes of applications that are really, really cool. The challenge is that as a user of those applications, something that can record audio so that you can take notes while you're driving in a hands-free way can also record audio and without your knowledge and ship it off somewhere else. And so there is a need for mobile applications to address what is this application allowed to do and in what context. And again, iOS and Android have a different approach to this. In the iOS environment, when an application needs to use a permission, needs to use your GPS or something along those lines, it asks the user to enable that permission, and the user is able to allow or deny. And then you can also go in as a user of the device and look to see which of these applications have I allowed to have access to my GPS location, for example. And I actually kind of like that because it lets the user make the decision at an appropriate time. In an Android environment, when you install an application, the user is asked, hey, here are the permissions that this application is asking for. Do you accept that or not? And so you have fairly fine-grained permissions that you can apply to an Android application, but those have to be accepted wholesale. And it's very interesting to look at apps in the App Store and look at the permissions they're asking for. And there are certain situations where applications need a lot of permissions, again, if they're going to be recording audio, transmitting video over the internet, but there's also situations where applications ask for a lot of permissions and where why does my flashlight application need to be able to record audio and send it over the internet? Well, it probably doesn't, and so there's a danger there that that application may be trying to do something malicious to users. And so, again, as an enterprise, you are making decisions, typically making decisions about what your application can do. And so this is less of a concern. It's more of a concern for users of the application. What am I allowing this application to do, and what are the personal security implications associated with me installing and running this application on my device? But it is something from a development standpoint to take a look and say, what permissions do we really need? How might this be misused if I have, again, if there's certain situations where my application can be tricked into doing something that it's not supposed to do. And that's something to certainly be aware of, and also from a brand impact standpoint to understand how the permissions you ask for, how those are going to be viewed by users of the application. If folks will remember a while back when Facebook split the Messenger app out from the normal Facebook app, there was a lot of uproar about, hey, look at all these permissions this app is asking for. This is clearly going to take, it's going to take all my photos and videos and ship them to Mark Zuckerberg. Whatever the concern was. It's important to understand as a developer of these applications, and as you deploy these applications, what there's a potential brand impact associated with asking for things that you don't need. For native code execution in iOS, what we see is a much greater access to there's much more frequent situations where you might have mistakes where you can run native code. Again, typically iOS application is going to be written in Objective-C that gets compiled down to ARM machine code, and Objective-C is not safe by nature, right? It is a superset of the C language. And inherits a lot of problems of the C language, such as buffer overflows, integer overflows. It has pointers. The Swift language does offer more protection, but still has, still gives you the capability to, gives you, plenty of rope to go and, shoot yourself in the foot. And so that's something to pay attention to. Again, having a language that is based on C that has pointers, that leaves a lot of pitfalls and increases the requirement for you to look and say, how are we validating this code that is that we're expecting to run, and are we opening holes where if we've got some sort of untrusted input that comes in that we may be able to cause some sort of native code execution. Again, Swift offers some protection. It doesn't directly exposed pointers, but has constructs like unsafe pointer, which at least is called unsafe, but again, at the end of the day, giving users the ability to do that and opens you up for problems. In an Android environment, again, the Java language and the runtime environments, the Dalvik or Android runtime, should provide much more safety. They have things like array bounds checking. They don't have a basic concept of pointers, and so as a result, you have less concern of, if you're writing applications in Java and using those runtimes, you have significantly less of a concern that accepting an untrusted input is going to result in native code execution. That being said, you can also run native code via the native development kit, and so much like Java allows you to run native code, Android in their environment also gives you the native development kit in order to run native code. The saving grace is that at least in situations where you're using or calling out to native code libraries that you're including, it's a cumbersome enough process that you at least notice. Similar to looking at on the server side, the .NET to COM bridge is pretty seamless, and so you can find yourself running native code and not maybe necessarily being as aware of that. Versus in Java, if you're calling native code, again, between the loading of libraries and all those other things, it's a little bit, it's enough of a hassle that you should hopefully be aware that you're doing it. And so, again, if you're developing for iOS, you have a requirement to pay attention to things like pointers, to pay attention to things like array bounds. In an Android environment, you have less concern about that because the runtime is going to step in and cause runtime exceptions and things of that nature. Again, if you have a requirement to use native code in your Android environments, then that may be something to pay attention to as well. So that was kind of the basics of running applications in these environments. The next concern is looking at data storage, right? So if I'm developing an application, if I'm going to store data on the device, what sort of protections do I have in place? And this is an area where there are both the raw storage capabilities for these, for these platforms. How do they let you store data on the device, and what native protections do they provide for data that's stored on the device? And also looking at what sort of encryption APIs or capabilities are available on top of the standard data storage that the device provides. Just to take a step back and look, the Android environment, as we talked about before, is based on the Linux operating system and inherits the protection model for files that Android or that Linux has, and that's clever. That's clever. That's great. With security, I'm not sure that clever is always better. So it's an interesting shift from taking Linux, which is a multi-user operating system, and translating that to be a single-user operating system, again, one person typically owning their mobile device, but using those multi-user capabilities to wall applications off from one another. Again, a very interesting use of those constructs, but one that is, can potentially cause trouble. In an iOS environment, you have one user, but they use separate controls based off of some of the trusted BSD stuff to wall applications off from one another. And so you have the ability to put applications in shared document spaces if needed, but by default, applications are going to be walled off from one another. When you're developing for Android, you have the ability when you're creating a file or a database or a property store or something along those lines, you can set, I want this construct to be private, or I want it to be world readable, or or world writable. And so you have the ability to control the file permissions associated with that in an explicit way. And so that's something to pay attention to. If somebody's ever making an application file that is world readable or world writable, as a security auditor, that's going to cause me to ask a question of like, why are you doing this? Are you trying to do some sort of inter-process communication in a weird way? What's the thinking behind making this this particular file or this particular data store world readable, world writable? Again, in an iOS environment, if you put things in shared documents, what's the thinking behind that? Also, looking at the just kind of the base file system protections. iOS since 3.0 provides some AES-based full disk encryption, which I would argue is a good thing. Originally based on burned-in hardware identifier, which is, has certain pitfalls associated with it. And with iOS, they added some hardware delay to passcode attempts, which is good, and moved more data under those default protection mechanisms. And so the good news is, on the iOS side, what we're starting to see is a lot more attention being paid to data storage on the device, and saying, if you recover someone else's device or a lost or a stolen device, you at least have to know the passcode in order to do this. In the Android world, from 5.0, they allow for full disk encryption based on a PIN or password. Again, that's a very good direction to be moving. And also the newer versions of Android have started to provide access to things like hardware-backed encryption via the trusted execution environment, which, again, are both things that are moving in the right direction. One thing I would caution you, though, as you look at protecting things on these devices is these protection mechanisms have been introduced, but they've also been found to have problems. And that's one of the things we'll look at more specifically here, looking at these encryption APIs that are available. The iOS devices, for a long time, has provided their keychain, which allows you to store things like cryptographic secrets that are protected in certain ways by the iOS hardware. And that's something that again, Apple, because they had a closed ecosystem, they controlled the hardware, they controlled the software for the operating system, they controlled what got introduced to to run on the device via their iTunes store. They had a better ability to do that earlier on, and it gave them, gave them some really good protections that were hard to replicate in an Android environment. And that's fantastic. The challenge is that these, that you can run into problems. Security researchers identified ways for them to find the entropy that was used to make the key, which allowed an attacker who found who stole or found a device. It gave them the ability to pull out certain subsets of data that might have been stored in the keychain. Furthermore, even items that were protected in the keychain but only stored or only protected, or they were also protected by the PIN. Well, the standard PIN is 4 4 numbers. That lets you have about 10,000 different choices, and 10,000 is a lot. If I was going to try them on a bike lock combination, I would probably get very bored doing that. If I'm a computer, doing something 10,000 times is pretty easy. And so, again, what has been found is there are ways, even with these protections put in place, there are ways that security researchers have found to degrade those protections or even get past them entirely. Android, a little bit late to the game, but now has a key store system, which is great, allows for more secure storage of key materials. And they also, again, now provide some of the capabilities that you used to only have in iOS. You can, well, my caution here is if you look at these security capabilities in either the iOS side or in the Android side and say, well, I'm going to use the key store, I'm going to use the keychain, and that provides security. So I can store anything on the device. That is a pretty brittle, a potentially brittle decision to make, because as I've mentioned, in the iOS environment, these types of protections have been found to be degradable or bypassable in the past. And to have a more robust security policy going forward, you really got to make some decisions about, do I really need to store this sensitive data on the device? At the end of the day, if you're storing encrypted data on the same device where you're storing the key to decrypt that data, that's, no matter what protections are put around that key, if those protections are bypassed, then an attacker has what they need in order to decrypt the data. And so, even using these facilities, and we certainly recommend that developers, understand these facilities, understand the capabilities that are available, and use them to the utmost. But also, when you're threat modeling your application, when you're making determinations about what do we store on the device, what do we have to recover out from our cloud or from from our server-side environment, really sensitive data where you'd have a catastrophic impact if someone we're able to capture that data. You've got to make some pretty tough decisions about that, even with these platform facilities in place. So from a threat model standpoint, that's an important thing to understand as you decide what operations happen on the device versus what happens on the server, and what data gets stored on the device, versus data that can only live, and persist on the server. Also, both iOS and Android provide access to common encryption libraries. iOS, again, has those APIs available. In an Android environment, it provides access to the JavaX.crypto APIs, and you can also use third-party Java libraries like the Bouncy Castle libraries. This is something, again, just to pay attention as you would with any library you're including to stay abreast of findings of vulnerabilities. I think in practice, the Bouncy Castle folks do a lot of great stuff, but we see a lot of mobile applications that have older versions of those crypto libraries that may have vulnerabilities baked into them. So that's something to pay attention to is, as you include these third-party components, are you keeping track of those third-party components with something like an OAuth dependency check or one of the commercial providers out there to identify situations where you have where you're inadvertently including a version of a library that has something, that has known vulnerabilities in that library. So now if we look, we've talked a little bit about data stored at rest and some of the facilities that are available to protect that data, as well as some of the pitfalls associated with storing that sensitive data. Now we can look at secure data communication. And that starts with just having the ability to communicate over the network. What are the platform facilities that are available? And also, once you're doing that communication, what ways do you have to protect that? And this is really important for mobile applications because mobile devices tend to talk on a large number of scary networks. Right? They're going to go to Starbucks, they're going to connect to unprotected Wi-Fi, maybe they're talking on corporate Wi-Fi networks where you have some more control, or they're talking over kind of the standard telco data provider networks. I think a lot of people pre-Snowden made a somewhat lazy assumption that the data being communicated across the telco networks was something that the average person couldn't get access to. Now that we're seeing things like the use of Stingray, again, other revelations that come out of that, and better realizing the capability of nation-state actors as well as other potentially less sophisticated actors, what you communicate from your mobile device back to server environments, that is something that you need to pay attention to, and you need to pay attention to protecting those. Again, from a network communication standpoint, iOS provides access to things like BSD sockets as well as implementations of many higher-level protocols. They make those libraries available, and so you can do that type of communication. In an Android environment, they provide access to your standard Java.NET classes, as well as native access to a number of HTTP utilities, and they also have Android-specific classes for things like HTTPS, SIP, communicating over Wi-Fi. And so you can drill into and understand the capabilities that are available for talking over the network. You can also protect network communications. In an iOS environment, they provide implementations of these common transport layer security protocols. And again, in my humble estimation, a lot of the default settings are not terrible. I don't necessarily want to say they're great, but the default implementations when you make requests out, do a pretty good job of saying if I find a certificate that is not, that is unsigned or that is expired, the default behavior is going to be to raise an exception or raise some sort of an error unless you explicitly go in and program around that. Similarly, in an Android environment, you have access to things like the JavaX.NET SSL classes for TLS network communications. And one specific thing in an Android environment, I would be careful using the Android.NET SSL certificate factory because they make it easy to disable protections. And as a Java developer who has written code that has to run both in production and in development where I maybe don't have valid SSL certs or TLS certs, as a developer, I really like situations where it's easy for me to disable those protections because it makes it easier for me to set up dev environments with less hassle. As a security professional, I don't like situations where it's easy to disable those types of protections because you assume, again, if you look and see, well, this traffic is running over HTTPS, you assume that traffic is going to be protected. What you would hate to see is a situation where the program or the application is willing to accept if their traffic is being proxied through something, some sort of a certificate and then proxied off, and that certificate is not signed by someone that's recognized. Another thing that we don't necessarily have time to go into today, but where we can provide some additional resources are things like certificate pinning, and that gives you some additional facilities you can use to say, if I'm talking over TLS to this specific site, I actually believe in the host that I'm connecting to. Again, a general piece of advice here is pay attention to code that runs in development versus code that runs in production, and any sort of disabling or weakening of these protections that may be, that you expect to be in place. Look for situations where developers may have, again, backed off of these protections, in order to make things convenient in development, when that also is going to impact the security of applications in production. Next up, looking at mobile browsers. A really interesting thing that we've seen, that I've seen kind of along the way, is that, especially early mobile applications, a lot of them were web applications stuffed into a, some sort of a WebKit control in the application. That's one of my friends runs a very successful company that does mobile application development, and they were one of the early on featured applications in the iOS App Store, and their application was essentially a web control that just had HTML rendered into it, right? So their mobile app was actually a very thin mobile or native application that called back to HTML to do most of the actual heavy lifting, and that was the fastest way to get to market for them. Made a lot of sense. Since then it's been rewritten as native code, or much thicker native client. But again, this is something to understand, that a lot of mobile applications, native mobile applications, render at least part of their user interface via mobile browsers. And so, again, from a mobile browser basic standpoint, iOS gives you a mobile version of Safari that sits on top of the WebKit HTML rendering engine. Those are controls that you can drop into parts, panes of your application, tell it where to load that data in from. Android similarly has a WebKit HTML rendering engine and a version of the Chrome V8 engine. And so these allows you to render web content in a portion, or all if you make the web control big enough, a portion of your application's user interface. There's also some interesting capabilities that mobile applications allow to help you provide a premium experience for certain users. And so what both iOS and Android do is they allow you to have applications register for different URL schemes. And so just like HTTP or HTTPS, those URL schemes are handled by the browser. You can use the TEL, :URL scheme, and the behavior, again, implemented in different ways, but available in both iOS and Android. If a user clicks in a web page on a link that starts with TEL and then has a number, the behavior of the operating system is to say, hey, the browser isn't going to handle this TEL URL scheme. Instead, the phone application is going to do that. And so what we're going to do is take the phone application, fire it up, and say, hey, you've got this message to call TEL 210-572-4400, right? And the behavior, correctly implemented, in both iOS and Android, the behavior of a phone app when it gets this message is to pop up a window that says, hey, do you want to call this phone number? So the user can say, yes, I do want to call that phone number, or I'm not sure what's happening, I want to cancel out of this. And so you can, and that's an example of a built-in application that has a URL scheme that it registers for. You can also, for your applications, register for different URL schemes, not the same one typically, or not the same ones as, that are used by built-in applications, but this is a way for you to say, if someone clicks on a mobile browser link and they have our application installed, this control is going to be transferred to our application. In an iOS environment, Apple applications given precedence for the scheme they register for, and in the Android environment, similar capability, and uses the Android intent facility to pass messages between or to that receiving application. In both cases, a developer should treat these inputs as untrusted, because, again, if someone clicked in the mobile browser on a malicious link, this could cause their application to be fired up and to have this, this data fed into it. A great example of a problem that existed with this before was the Skype mobile application, where you could, if the Skype application was installed with a much older version, but if the Skype application was installed, if the user clicked on a link in a web page that had a Skype URL scheme in it, it would just go and call that number. It didn't go through the step of confirming. The application didn't confirm, do you actually want to call this Skype number? So again, if you're developing applications that take advantage of these facilities, you can provide some really cool behaviors to go between mobile browsers and your, and your thick client mobile application. You need to understand how these messages get passed, and developers should treat those inputs as untrusted. Similarly, both iOS and Android allow for SMS messaging and push messages. And these allow applications to receive these push notifications so that they can display a message, download new data. Android used to have the cloud-to-device messaging framework. It's been deprecated and replaced by the Google Cloud Managing. And in both of these cases, it's similarly important. You don't necessarily, or you certainly shouldn't, as a developer, trust the data that is coming from these push messages. You need to treat that as hostile, validate it, and then make a decision. Do I need to confirm something with the user, or what other, do I need any additional confirmation before I take whatever my default action would have been? And again, in the secure mobile development reference, we've got links to some additional information about the mechanics of how these facilities work. Similarly, for application licensing and in-app payments, this is something where both in an iOS and an Android environment, they let you do things. You can allow users to buy additional content. In the iOS environment, the StoreKit API allows for those types of capabilities. In an Android environment, the billing API allows you to proxy these types of communications with the relevant services. Again, these in the secure mobile development reference, we provide links that can guide you to understand more how these capabilities work and how you can call into these capabilities from your particular application. So where do we go from here? As a security person, I think it's really important for security folks to understand the threat model, at the very least understand a general mobile application threat model, and to understand the peculiarities of the platforms that your organization supports. Again, you may have a desire to only support certain, certain languages or certain platforms. The unfortunate thing is, again, that's typically going to be determined by the market, not by your security analysis of the security of the platform. And so to a certain degree, the market is going to tell you, or the business line is going to tell you what they want to do, and it's up to you to figure out how can I enable this value creation for this line of business while mitigating the risk. And that's something that we've found, again, it's a kind of a general recurring theme in information security, and it certainly becomes even more the case in a mobile application environment, where if you look at the opportunities for innovation from mobile and the cool new things that organizations can do to build value for their constituents, mobile is, again, it's going to be a priority. It's the pointing into the spear in a lot of cases. People are doing cool things. From a security standpoint, you don't want to get in the way of these. You need to say, I see what you're trying to do, and here's the way you can do that that's going to help minimize the risk or going to put us in the best position. Really, really important. And this gives you an opportunity to work with developers to go and lay out architecture, design, and coding guidelines and standards. Right? This is an opportunity to provide resources, again, like the secure mobile development reference, as well as the materials it links to. This is an opportunity to say, I see what you guys are doing. Have you put coding standards in place that is going to help us to minimize the risk of buffer overflows? Or, hey, if you're using the URL schema registration, make sure, have you done abuse cases to say, what if I get messages that that don't come preformed like I expect them to? This is a great opportunity for security folks to act as a resource for developers to help provide some insight to the developers on the security pitfalls, but also the security facilities available for them to take advantage of. This is also something where you need to test the security of mobile application systems. Again, today we've focused very much on code running on the device, But from a threat model standpoint, it's important to understand it's not just the code running on the device that is going to impact the security of your organization. You also need to take into account the security characteristics of the web services, again, not just the code running on the device. But hopefully with the resources you have here, that can help to provide developers the facilities they need so that the code running on the device takes the best advantage of the security capabilities that are available. From a developer standpoint, again, threat modeling is a tremendously valuable technique, especially as you start to move away from web applications where hopefully everybody now kind of understands the threat model. But if you're moving toward mobile applications or IoT applications, you're starting to play more three-dimensional chess where you've got potential problems coming at you from different directions rather than just the bad people outside your firewall. And as a result, threat modeling is a way early on where you can help catch potential problems. And so that's a technique that is really, really valuable in finding problems and addressing them early before you have an installed base of some number of users as well as web services where you've got to start doing versioning and things of that nature. It's also really important to understand the security properties and capabilities of the platform that you're developing for. And that's, I'll be honest, that's a little bit of an ask, but as a developer, I think that's something that's very important. Secure coding is something that not everybody needs to be an expert in, but needs to at least have a background in. And as you're learning about developing for iOS, as you're learning about developing for Android, it's also very valuable to take into account the security capabilities, the security features, as well as the security principles that underlie the application platform or platforms you're developing for. That puts you in a position where you can make good decisions early on, again, that don't have implications down the line. Again, if you want to be an expert iOS developer, an expert Android developer, part of that is keeping current and and paying attention to the evolution of these platforms. As I've mentioned along the way in a number of situations, like the Android platform started from one place from a security standpoint and has been able to layer in additional security capabilities since then. And so that puts you as a developer in a situation to say, hey, this percentage of our folks are all, people are all moving to Android. We can start making potentially different decisions because we have new security capabilities available to us. So it's important to keep abreast both of new security capabilities that are available as well as potential weaknesses that are identified in these platforms. Because that's part of your responsibility as a developer to develop software that's going to keep your organization secure while you're providing these great capabilities. Really recommend everybody take a look at the secure mobile application development reference. That goes through a lot of the material, or basically all the material we've talked about today, but as I said, peels back that onion one more layer and provides links to specific resources. And that's something that we update over time and try to keep reasonably current as a reference both for security professionals and for developers. And now, what we'll do is turn things over for a couple of questions. Two questions. Oh, all right. First question we've got is, the question submission is, what about the web services supporting the mobile apps? How do developers secure these? Great question. And again, most of the material we've talked about today has been very specific, or it's focused in on code running on the mobile device and the security characteristics of iOS and Android. I would argue that it's even more important to pay attention to what goes on the server side, because if you find a vulnerability on the server side, you potentially have a much greater set of users that are affected. And so those are cases where, when you look at securing the server-side resources, again, very important to understand. You need to expect, number one, that adversaries are going to be able to find those and send adversarial traffic to them. Really important. We see too many web services that are built assuming nobody's ever going to be able to find this, or the only requests we're ever going to receive are from our approved mobile client. That's a scary and ultimately brittle decision to make. So that's That's something to be aware of. You want to do input validation for stuff that's coming in. You want to do output encoding for, as you send things back for database queries, all the standard web application secure coding stuff that hopefully people are becoming more familiar with. Also, authentication and authorization. How do you, how do you know who is requesting this application, or is making this request to the web service, and how do you know that that user should have the right to do whatever they're asking for? Session management is a potentially challenging thing. Another question, see the events being recorded? Yeah, it will be available for viewing after. I was going to promise that it would be available today, but the marketing people glared at me and said it will be available shortly. So no, that will be available here pretty quickly, and everybody who registered will get an email about that. Next question. Area concerned with the opinion on reverse engineering where code or sensitive info is disclosed to an adversary. Okay, so a fact of life with mobile development is that you have to expect that people are going to reverse engineer your code, right? And so, and again, there's some protections in iOS where they do encryption of the binaries. As we've seen, those are pretty trivially bypassed. And I would argue that those capabilities are in there not for the security protection, but instead to protect the licensing model that the Apple iTunes Store has. Maybe that's the cynic in me. So from a threat modeling standpoint, I would assume that any code that you any code or any secrets that you embed in the application are going to be discovered. And so if you have intellectual property that is protected by trade secrets, for example, like the formula to Coke or the spices that go into the KFC recipe or something like that, a bad place for those type of secrets are in the mobile code or data that's going to be loaded on the device. And so, so from a design standpoint, that's an important thing to understand. When you do your threat modeling, you should understand the, you should expect that those things are going to be identified and design around those. Again, you may make a risk decision to say we need to embed this stuff here, but if you're looking at embedding things like passwords, again, sensitive algorithms, stuff like that, assume that reverse engineering is going to find those, because if you don't, you're probably going to be sad down the way. Additional concerns with apps being additional concerns with apps being integrated with smartphones and smartwatches. That, again, takes the mobile application threat model and adds another device and communication to that. And so with smartwatch applications, especially ones that are calling up through the mobile device, you apply the same principles, but understand that you have to look at the communication between the smartwatch and the smartphone, similar to the way that you look at the smartphone communicating out. And in a lot of cases where they're talking over Bluetooth, or I don't really very much trust Bluetooth security, that's something where you need to where you need to pay attention to those similar things. What data am I storing on this device in case it's captured? How am I communicating this data? Am I communicating it over appropriately secure TLS? How do I authenticate these communications and do authorization? Another question looking at dual factor authentication via SMS for mobile web applications. I like dual factor authentication using SMS because that gives you an alternate factor. Challenge being, though, if in the case of a lost device where someone has access to the device and you're sending SMSs to that device, the value of the SMS is saying, well, that's something you have is that mobile device. So for web applications, I think that SMS two-factor auth can help to add to security. If you're looking at an application being accessed from the device and that sending SMSs to the device, you really haven't added another factor there. Another question about having a number of mobile devices connected to the same Wi-Fi network. And looking at the communication on the Wi-Fi, how can devices communicate with one another? That's something where we've looked at, we've seen a number of applications where they do things like open up, HTTP ports. Applications will open up HTTP ports so that local things can talk to them. That you can do some interesting stuff with that, but I can't think of a case where we've seen an application that tried to do some sort of like on the local Wi-Fi mesh networking stuff where they haven't introduced some pretty serious security vulnerabilities. That's something just where where we just haven't seen anyone do it. We haven't seen someone have a lot of success doing that very successfully. And so you certainly can communicate between on local Wi-Fi networks with between mobile devices. It's really hard to do things like authenticating the devices to one another, and because of that, it's hard to make authorization decisions about what type of stuff to make available. We've seen some really kind of gnarly stuff in assessments where sensitive files stored on devices get exposed via web servers that are running on devices that get opened up for, again, some sort of a cool feature that someone wanted to implement, but something where if you look at the value of that feature crossed with the security implications or the challenges with securing that communication, where it's just not worth it. So some questions on Android fragmentation. So that is something where keeping up to date with an iOS, with the iOS environment, even when Apple controls the entire ecosystem, that can be challenging enough because you have multiple hardware devices that are upgraded over time. You have iOS versions that are upgraded over time, and so you end up having to say, well, we've got this device and this version of iOS. What capabilities do they have? To make a tough situation really horrendous, just take a look at the Android world where you have multiple carriers, multiple device makers, and multiple versions. Coupled with the fact that a lot of carriers don't, do a pretty, well, I'd say a really bad job of keeping their Android versions patched. And so as a result, that causes problems both from a security standpoint as well as just from a general design and usability standpoint. And so, again, a number of things we talked about, hey, Android version 5, Android version 6, they've got these new neat capabilities. That's cool as long as you have users that are using that version of Android, right? And that may allow you to make different decisions. You may decide, hey, the key store now provides acceptable enough security that we're going to, do, whatever. Now we'll store this thing on the device, which lets us do this new capability that we did not have otherwise. The challenge, though, there is, does that alienate some set of some set of users? And the unfortunate impact in a lot of cases is that you write to the lowest common denominator, or you look at the you collect some data from the users to identify what versions of Android are we seeing in use, where you can then say, you know what, once the usage gets down to 15% or something like that, or 10% or whatever your business decision is, you'll say, we're willing to force people to upgrade or to make this unavailable to some set of users in order to have access to this better capability. That's just a really challenging thing in an Android environment. Is again, they've done great things and made tremendous strides getting parity with iOS in a number of areas. The unfortunate thing is iOS just has a much longer history of having those capabilities out there, and thus a much stronger installed base of devices and operating system loads that have access to those capabilities. So that's a really challenging problem. a question, I touched upon this a little bit, but Apple and Google, what do the app stores do for testing? They're pretty sneaky about what exactly goes on in that type of testing. Again, as I talked about before, in our experience with the Apple folks, they've got recommended guidelines on things that you need to do. A lot of those are centered around, is the look and feel consistent? Does the application behave, as appropriate? With some hand-wavy stuff about security, which in a lot of cases means checking for calls to banned APIs that they don't want you to use, as opposed to things that maybe necessarily have a huge security impact. There are some things that we think they're doing, but they haven't been super transparent about that. I would contrast that with in the Android space, where again, there's traditionally been a lot less testing going on. They adopt the model more of let's get a bunch of apps and let them out, and then we'll rein in the ones that misbehave. A couple years ago, though, Android did based on a huge explosion of malware or malicious applications existing in the Google Play Store for Android. They started to do some malware detection along the way as well. Again, and that has helped from a user perspective, that has helped to decrease the amount of malware or malicious applications that are in the App Store. For the typical organization that we interact with, though, which is large, finance, insurance, healthcare, folks that are deploying apps to their customers, the malware detection, doesn't really have a strong impact on the lives of their developers, because the developers are hopefully not including malware in the applications they're submitting to the store, right? It's certainly a security concern. It's not a security concern that the organization can do a lot with, except, and again, this is less of a developer task. From a risk intelligence standpoint, having security folks, look to see, are there, if I'm a financial institution ABC, am I searching, and ABC is probably a bad example of an acronym, but am I searching the App Store for ABC to identify if there are malicious or fake applications that purport to be from my institution out there? That's something that we've worked with some organizations to do to, again, this doesn't impact the lives of developers because there's not a lot that they can do, but it is something that the security folks can do to say, not only, asking the question, are we deploying applications that are as secure as possible, but also saying, have other people maliciously deployed applications that are attempting to spoof or emulate our stuff in order to undertake some sort of nefarious purpose in addition. All right. Well, I think that's all the time we've got. We went a little bit over, and we still have a bunch of folks here. So thank you guys for hanging out with us and for the duration. And again, I'll turn this over to Nan, and he can talk about what's going to be available and when.
Great. Thank you for attending this Denim Group webinar. We will follow up soon with the slides, the recording, and we'll also follow up with a link to the guide, as Dan had mentioned. So you may now disconnect. Thank you again for joining us.
Thanks, everybody.